Okay, today we're going to talk about regular expressions. Have any of you heard of this term before? Anybody? No? Okay. Well, you have now. And this is actually something that you've uh, actually dealt with a little bit. Imagine, have you ever been like on a website where you're kind of, say, registering for something and they say, okay, put in your email into a little form. What happens if you put in something that isn't an email? I mean, not whether or not it's a legitimate email, but you put in something that isn't an email at all, just arbitrary text.
Generally get an error.
Okay, so now how do you get an error? How does how does that form know that that's an error?
Whatever you put in doesn't match what they're expecting.
Okay, yeah, exactly. So now, how do they know what to expect? Do they have a list of all the possible emails and say, are you part of this list? If you're not, then it's not a real email, or what? What does an email have to have? You have sort of a name, and then an at, and then a domain. That's the way it usually works. So how does it know that if you type in something that doesn't have a name with certain and have only one at sign and not zero, not two, and then a domain after that? How does it know that? I mean, imagine writing a program that figures that out, or is writing some logic. Does that seem like a trivial, easy task? Yeah. No. And that's what regular expressions are. Regular expressions are a way of matching something like that. In other words, behind the scenes, there is a regular expression that says, I will only match things that have a name, and there's the restrictions on that, on what that name can be. I mean, it can't have, it can have dots, it can have letters, it can have numbers, but I believe it can't start with a number. It can't have like hashtags and dollar signs and other types of things in it. And then it has to have an at, and then it has some other stuff. So there's behind the scenes, there is something called a regular expression that matches that pattern. And so we're going to dip our toe into that just a little bit. You've already used a little bit of element of this. Have you ever searched for, say, all doc files and used something like star.doc? Okay, so that's a regular expression. That star, what does that star mean? That star says match anything that comes up to the dot, and then after the dot it has to say like docx or something. Okay, so that's that idea is kind of writ large is what regular expressions are about. Regular expressions, and I mean, in fact, there's a whole, we could spend easily the whole quarter or more kind of delving into what that is. It's a whole language in itself. And maybe what you're getting a sense of is that when it comes to navigating the computer environment in today's world, depending on what your task is, you need to learn a number of different languages. We're learning a programming language here, but there are, well, if you're doing web stuff, there's HTML. If you're doing a lot of data stuff, there's XML. If you're doing database stuff, there's SQL. And if you're doing this task, then knowing at least a certain amount of this regular expression stuff is important. We saw a little bit of that yesterday when we were analyzing the words that were in this text document. And we saw that there were a bunch of things that no reasonable person would consider to be a word. And so the task that was kind of presented to us, and by us I mean me, because I'm the one driving the train here, but But the task is, I mean, if you're encountered with that, I would say count the words, and it's counting things that aren't words, then okay, now how can we address that? We can address that using regular expressions to say, this is how I define what a word is. And in the context of text, it's words in text are more restrictive than words in programming. Like in a programming language, well, like in Java, there are constraints on how you can define the name of a class, for example. There are constraints on how you can define the name of a variable or a method. And so how does Java know that you've typed in something that isn't a legitimate name? Well, again, there's some sort of pattern matching that goes on that says that, it can't know every possible name, but we can kind of do that. So it's about matching text. And then to that, you've already used many times a wildcard, the star. That's an example of a wildcard. It turns out there are some other wildcards you can use that are give you a little finer use of that. And then, like any language, there are certain meta characters. In programming languages, kind of the meta-like things are reserved words. So, for example, you may have noticed that you're not allowed to define a variable called class. Why? Well, because class is a reserved word. In other words, you can think of it as a meta word, because it's a word that describes something, and because it describes, in this case, the definition of a class, you can't use it in another context, like for a variable name. So that we'll look at matching words, and then the other main use of it is in splitting strings. So one of the tasks, like if we're processing data in the form of a comma-separated file, for example, then our data comes in the form of lines that are separated by a comma. They could be separated by a semicolon. And later we will see an example of tab-separated files, where the delimiter is actually a tab instead of a semicolon. Okay. So just with our little peek into that, just after what you learned today, you'll be able to construct a regular expression to match a certain portion of a string, in fairly simple one. We can also use it to replace parts of a string. In a sense, you've used the replace. You've all used the replace function at some point, right? Say, okay, replace all occurrences of this with that. Usually, we use it to replace a specific string with another specific string, but it turns out we can use regular expressions to make that more powerful. We can say all pieces of strings that match this pattern replace with this other thing. And then so we'll see. The example we'll see is splitting a string, using a comma, because that's a very common one. But then it turns out that sometimes what happens is, this is sort of symptomatic sometimes of comma-separated files. There are often extra spaces in them. I've kind of encountered this a lot in other situations, where if I just split it on the commas, then all these other spaces start creeping in, and it turns out we have a way of saying, okay, instead of just a string, sort of a string with spaces and stuff, we'll see how to do that. Okay. So what is a regular expression, sometimes called regex? Why? Because when it comes to these computer things, people like to, it's like we don't like to do a lot of typing, so we always kind of abbreviate things. You couldn't possibly understand that because you never have to deal with acronyms and things like that in what you do. Okay, so the three main uses, matching text patterns to identify certain portions, matching them to replace, and then splitting. Those are the three main uses I won't say for everybody, but these are the three uses that I've, in my experience, have done. So, okay, so now here's the kind of the first meta character. Well, first, just regular text, it can be thought of as a regular expression, and so when you think of searching for all occurrences of a particular specific text, that's a regular expression as well. So even though it's a specific set of strings, we've seen this the star or asterisk meta character says match 0 or more of these things. We'll encounter then, but a dot matches one character of any kind. Whereas a letter or a number matches the exact character that it is. So, for example, so here's a string of characters, and this is all case sensitive, by the way. So, hi mom, like this with a space there, it matches this text and nothing else. That's it. And so, when you've been searching for things using a specific string, it'll match that, but then nothing else. However, if I say hi dot mom, and the thing to understand is that a dot doesn't mean match a period. If we want to match a period, then we actually have to escape it, which will. But if I say hey dot mom, it'll match this with a space. But it'll match hi X mom or hi $ mom or hi, in other words, it will match anything with any character whatsoever between hi and mom. Okay, but just one character. So if it were a star, then that would be a different thing. However, see, because it doesn't match here, it doesn't match this because there are two. So the dot matches, so what it looks for is, it says, okay, the string has got to start with capital H, lowercase I, and then the dot says any one character in between. So here's one character, matches this, but then here we find two characters and say no. And here we have no characters. And then here we have two again. Okay, do you see how that works? So if you want to match one character of any kind, so it's like if I'm looking for, if for whatever reason I have this string here, I have like these two strings, and then I may have some garbage one character worth of garbage in between, and then I can sort of match whatever that is. Okay, the second thing, that the angle brackets, or square brackets, sorry. This allows us to give a choice. So, if I put A, B, and C in brackets like this, then this will match one of those. Exactly. So, this will match A, it will match B, it will match C, but it won't match D or 6 or anything else. Okay, now supposing I want to say, well, I want to match any single lowercase letter. So this thing will match exactly one letter that's either A, B, or C. Now it turns out that they have some shorthands for things. So supposing I want to match any lowercase letter whatsoever, any single one, well, A hyphen Z means all the lowercase letters A through Z, and that will match any single lowercase letter whatsoever. So that'll match A, B, C, D, whatever, but it won't match 9 or $sign or at or anything like that. And if I want to match a single letter of either case, then I can simply say A through Z lowercase, A through Z uppercase. Again, all of this is always case sensitive. So this will match any letter of either case. So for example, if I take hi mom and I put hi in brackets and mom in brackets, this will match any two letters where the first one is either H or I, And the second one is either M or O. If I want to match numbers, then 0 through 9 will match any single digit. So if I encounter this, then this will match, 0, 1, 2, 3, 4, etc., but it won't match a letter, or it won't match a dollar sign or a hash sign. Now, it turns out that if we put an up arrow inside this is sort of confusing because the up arrow actually means two different things depending on whether it's inside the bracket or outside the bracket. So if I say up arrow and then followed by any sort of stuff, then this will match any letter except A, B, or C. So this will match D or Z. It won't match 3. But so what I'm doing is I'm saying I'm negating this, and similar here. This will, if I say not A through Z capital, this will match any character except a letter. And wild cards. So we've seen the star, and we've seen the dot, which is also would match. A dot matches one of anything, but then that's kind of a question mark will match 0 or 1 instances of it. So if I say hi mom question mark, what that says is that the thing right before it, it'll either be 0 or 1 of these. So there'll be either 0 or 1 M's. So this will match hi mom because there's 1 M, but it'll also match hi mo because there's 0 M's. But it won't match, it won't match this one because there's more than 1 M. But a plus will match 1 or more. So if I say hi mom plus, that'll match hi mom, but it'll say hi mama mama mama. So there's more than 1 M, and the plus says match, match more than 1. But this will not match hi mo because there's 0. It doesn't match 0. It's 1 or more. And then star, which you've all used and are used to, will match 0 or more. So hi mom star basically will match any of these. And the star in this case refers to the M. So 0 or more M's. So it'll match this because there's 1. It'll match this because there's 0, and it'll match this because there are more than 1. Okay, before I go too much farther into this, let's look at some examples. This can kind of seem a little abstract till you start playing with it. Okay, in the class code, if you do a pull, there's now a package called regex, and okay, so here this wasn't the slickest thing, but it was just illustrated. So here are a bunch of tests. So here are just some of the things that I've various things of hi mom. And so here's the regex hi mom with the dot, and then we'll see what that matches. And then for this one, okay, so here are a bunch of single letters, A, B, C, D, whatever. And if the regular expression is bracket A, B, C, and then we'll just kind of loop over it and see whether it matches. It should match A, B, and C, but not D or 5. And then here's the negating one. So this on the same one should not match A, B, or C, but it should match D and 5. And then let's see, so this is not those. So this should not match A, B, C, or D, but it should match 5. And then finally, Yeah, here's the one, the question mark, the plus, and the star. All right, so let's see what they do here. Okay, so hi dot mom, it matches hi mom, yes. It matches hi x mom, yes. It matches hi dollar sign mom, yep. But then h9 mom, false. And then hi xx mom, nope. Hi mom with nothing there, nope. And then 2 @signs, nope. So, all right, so here A, B, C, does it match A? Yep. B, it matches C. Doesn't match D. Doesn't match 5. Okay, when I negate it, it doesn't match A, doesn't match B, doesn't match C. But it does match D, and it does match 5. But if I negate all letters, upper and lowercase, it doesn't match A, B, C, or D, but it does match 5. And then here's the question mark, which is 0 or 1. It matches hi mom, and it matches hi mo. But it doesn't match hi mom because there's more than one. But if I put the plus, then it, matches hi mom. It doesn't match hi mo, but it matches hi mom. And then finally the star, that matches hi mom, hi mo, and hi mom. So you see how that goes? Okay, so now we can combine these. So far all of these are referring to just kind of like one character. You're going to say, well, if that's all we can do, that can get kind of difficult. But here, when we add these wildcards together with things like character ranges and options, we can now have a much more expressive type of thing. So here I have A through Z. This piece matches one lowercase letter. The plus, though, says match one or more lowercase letters. So the plus refers to the one thing immediately before it. The one thing immediately before it is any lowercase letter from A through Z. So that will match hi mom, but it won't match the empty string. It won't match hi mom with capital H because that wasn't included here. It certainly will, even if this were lowercase, it wouldn't match this because of the space. So with this will match any sequence of letters that are all lowercase, and not match anything that has just anything that's not that in there. Now if I make it a question mark, so that will match one lowercase letter, or nothing. So remember, the question mark is 0 or 1. So it will match the empty string, and it will match the single letter H, but it won't match hi because that's 2 letters. And if I put a star, that's 0 or more of these things. So it'll match the empty string because that's 0 of them. It'll match hi mom, but it won't match this because of the capital, and it won't match this one because of the space. Now if I had A through Z lower and A through Z upper, for example, so the plus, if I did that with a plus, that would match this, but not this. And if I did the same thing with the question mark, that would match this, this, and this, but it would also match an uppercase, a single uppercase H, if I had the question mark, and then if I had the same thing with the star, that would match this, this, but it won't match this because of the space. So hopefully you're starting to get a sense of how we can use these to put together, if we're looking for a particular pattern in which we don't have to match it exactly, but we can match pieces of it exactly and other pieces that are that might be sort of questionable, or that then this is a very expressive language, and it can get how should I say it can also be a little confusing. So now it turned out, when they were kind of developing this back in the day, then it turns out that it was desirable. Like a lot of things kind of kept coming up, and they wanted to save keystrokes. Why? I mean, a lot of the things that we that are kind of around are vestiges of a time when computers were just really, really tiny. I mean, you've probably heard this, but the computing power of your cell phone is orders of magnitude greater than the computing power that NASA used to put a man on the moon. So, which is kind of mind-blowing if you think about it. But the computers were kind of, I think I might have shared this, that they these sort of geniuses at AT&T Labs back in the day invented networking because they wanted to format documents and print the documents, but the computers that they had weren't big enough to do both at the same time. So they invented a way to format it on one computer and then send it to another computer to drive the printer. So it's like, and that's where according to the stories I've read, that's when networking was invented, not that they said, oh, let's have a World Wide Web that where people all over can watch cat videos. So then, if you could go back to 100 years and sort of tell people what it says, well, we have these devices that we carry around that we have the entire world knowledge at our fingertips, and we use this to watch cat videos and complain about things and post memes. So anyway, okay, so meta characters. So they say 0 through 9. You say matches any digit, and that was something they said. Well, let's have an abbreviation for that, and the abbreviation so the meta characters are escaped. So you understand the notion of escaping something with the backslash, which is why the vest, the things that kind of decisions in the past. So the decision of CP/M to use a backslash to separate path names on the file system sort of came all the way to DOS, which has led to Windows, and so using the escape character as a path separator is actually a kind of a stupid thing, but got to deal with it. Okay, so and now and when it comes to regular expressions, we have to deal with the same thing, as you'll see, because when we express it as strings, we need to you'll see when we write these, we actually have to double up on the backslashes. That's just kind of we're kind of stuck with that. Anyway, so \D for digit matches any single digit. So it's a synonym for 0 through 9, but it's a little less typing. So \D will match 1, but not 1 1 or A1. And the opposite, and then the pattern is that the lowercase will match, but then if you turn it to uppercase, it negates it. So \D matches anything that's not a digit. So \D, it'll match H because that's not a digit. It won't match this, well, neither one's a digit, but it won't match 8, or it also won't match 81, for example, because that's 2 digits. Now, as we saw with letters, it turned, and this actually kind of goes back to, in the early days, whenever, if you remember, I kind of ranted a little bit about whenever you're using a particular thing, it's always best to use the idiom of that thing. And in the case of programming languages, there are different conventions for how to name things. So, for example, in Java, the convention for naming classes, variables, and methods is camel case. Why? Because when you have a longer name of something, if it's all the same case, then it's kind of hard to read. When you have a way of splitting up the individual words, then it's easier to read. But in its predecessor, C, the convention was everything. They were kind of reacting against Fortran. In Fortran, everything was all uppercase, and your variables couldn't be longer than 7 characters. So imagine trying to write stuff in that these days. But C said, okay, no, we want our variables to be more descriptive, but because we don't like Fortran, we're going to make everything lowercase. And if everything's lowercase, how do you kind of have that separation? If I have a long variable name that's descriptive, but it's got kind of 2 words, how do you separate them? They decided to use everything lowercase for another reason. And then they said, okay, we'll use underscores to separate them. That's the idiom in C. That's also the idiom in Python. So like if you're writing in Python and you use camel case, then you're kind of putting up a red flag that says, oh, I'm really a Java programmer and I'm kind of an interloper. Likewise, if you're writing in Java and you have lowercase things with underscore, you say, okay, you're probably a C or a Python programmer who's kind of sneaking in here trying to do your horrible naming things. Anyway, so that's my take on why a word includes letters, numbers, and underscores. And I believe this came from, just sort of C conventions for naming things. So we saw before, I can specify a letter, and if I add 0 through 9 to that bracket, then that'll be letters and numbers. And if I add underscore, then, so basically, they say, well, a lot of times the names we want to match are consist of all those things. So backslash lowercase w will match a single letter, a number, or an underscore. So those are the elements of what a name is. So backslash, it'll match a lowercase h, it'll match an underscore, it'll match a 4, but it won't match an at, because that's not one of those things. And then if you flip that, backslash capital W will match any single character that's not a letter, number, or underscore. So backslash capital W, it'll match at, it'll match $, but it won't match any of these. Okay, these are those are okay. Those meta characters, and then the other one, and there are more beside this, but these are the main ones that I use. So white space. When I say white space, is that okay? Basically, a white space is just a tab, a space, tab, new line, or carriage return. These days, it's kind of hidden from a lot of us, but all the major operating systems have a different way of telling the printing to go to the next line. So and the way that that's represented is so for example in DOS it was carriage return and new line, whereas in Unix it was just the new line, and then I think there's another one that I sort of forget, but it turned out that okay, so all those are white space, tabs, new lines, carriage returns. Those are all white space because when you look at it, you can't see it. That's why, to me, when Python made white space meaningful, then that was kind of one of the dumbest things that any language has ever done. I don't know if this has ever happened to you, but if you're writing a Python program and like a tab slips in where there should be a space, then all of a sudden the program doesn't work. You look at it, it looks fine, but it doesn't work. So that's good. Okay, so anyway, sorry, that's my biggest beef about Python. Okay, so backslash lowercase s matches any white space. So here's a space, here's a tab, here's a new line. It'll match any of those. And if I want more than that, a lot of times this appears. So it's like, and this is kind of what can come up. If I plus it now, a backslash plus, that'll match one or more white space in any combination. So if I have spaces, tabs, new lines, and just any blob of white space, I can match that, and then if I want to say replace all sequences of that with just a single space, then I can do that. And as is the convention, if I uppercase that, capital uppercase S matches any non-white space character. So capital backslash capital S, it'll match anything except one of these spaces. So let's see, that is plus. Okay, this shouldn't be there. That way it won't match that, but it'll match this. Okay, so now the thing is that, and here's the problem is that when you want to convey a backslash, because a backslash is an escape character. When I'm using this now, and this is true of all situations where we're using regular expressions, I have to escape the backslash to convey it in a string. So if I want to use one of these meta characters, I have to backslash. I want to convey backslash s in the string, but the only way I can do that is by escaping the backslash. So in other words, and this is the problem with meta. So within the string, the backslash itself is a meta character, and so how do I tell the string, oh, I don't want to use the backslash as a meta character, I want to use it as a backslash? Well, you have to escape it. So a backslash is one of those. Now, one thing don't think if you remember also, the dot is another wild card character. So what if I want to match an actual dot? What do you think I have to do? Escape it. Yeah. So if I want to match an actual dot, no kidding dot, I have to escape it, and to escape it, I have to kind of escape the escape, and so this will match an actual dot. So if I use this is a wild card, so this will match any single character, and this will match a dot. Yes?
So what would happen if you went one backslash?
You get a syntax error because your strings only allow there are only a certain number of things that are backslashable that are so backslash t is a tab, backslash n there are probably a couple others, but if it's not one of those and you're trying to escape a non-escapable letter, it'll say nope, can't do. Yeah. Okay, so you can get even more sophisticated, and so remember I said that the up arrow has two different meanings, and this was a little unfortunate, but that's what they did. If we put it at the start of an expression outside of the square brackets, we put it inside the square brackets, it negates what's inside the square brackets, but outside of it, it means the start of the expression. So in other words, if I say up arrow high and then and then a space, and then one or more words, which, well, again, a word character would be letter, number, or underscore. So that would match this because it starts with hi and then that, but it does not match this because this doesn't start with the hi thing. So what this allows you to do is search for all things that start with a certain, in this case, start with hi and then a space and then one or more letters, numbers, or underscores. At the other end, the $ specifies the end of a string. So let's look at this. So I have hi, a space, one or more words, and then the letter M, and then the end of the word. So that will match hi mom. And okay, so we got a hi and a space, one or more words ending with M, but it won't match this one because it does not end with a lowercase m. And then the pipe will match either what's before it or what's after it. So if I want to say, okay, either match this or that, and this often comes in if I'm looking for, let's say I'm looking through email types of things, and I'm looking for either CC, BC, either to CC or BCC, because I want to get all of the different things that are, all the different addresses. So I could say CC pipe to pipe CC pipe BCC, and that would match one. Every time we would encounter that, then what came after that would be a list of emails. What if? What if there were? Then it would. It still wouldn't match it because it would only match HI or MOM. So even if there were no space, it still wouldn't match that. So yeah, because here, again, just a specific string without any of these other weird letters is a regular expression, but it says match this exactly. So this has to match HI exactly or MOM exactly. And you can have more than one of these. You can string them out. Okay, so just some more examples. So like up arrow bat, this says has to start with bat and then have one or more words. So so that will match bat. It will match Batman, but it won't match wombat because it doesn't start with bat. Yes. Correct. Correct, because of the space. Yeah, good point. Okay, so here are 0 or more word letters followed by bat and a $. So that'll match bat because 0 or more and ends with bat. It'll match wombat because it ends with bat and has word letters before it, but it won't match Batman because it matches the bat, but it doesn't end with bat. Okay, so remember, lowercase d matches any number, and so \d plus will match any integer, but it won't match a floating point. So what do I do? What do I have to do if I want to match a floating point? Well, and remember that these come in all kinds of different. You can see it gets kind of. I should say it's like it can be. I've had more than my degree of frustration in trying to get things that actually match. So when you do programming, frustration is a state that you have to get used to. Okay, so let's say I want to match floating point. So the thing about floating point is that There's going to be a dot, but there isn't always a number beforehand. Sometimes I see floating point things and they don't have the decimal part. So if I want to match that, then I have, okay, \d star that says 0 or more numbers, integers. Here's the actual, no kidding, decimal point, and this is where it's easy to kind of screw up. Where if I don't \, that, then it's going to match just sort of anything. And then one or more decimal points. So I have to have at least one number in there for it to even be something. So that'll match this and this, but not this. Why? Because it's missing the dot. So how can I match either floating point or an integer? Well, I can use the question mark now on the dot. So the dot's either there or not. So I have 0 or more before the decimal place, and then either a dot or no dot, and then 1 or more digits following that. So that'll match this, and this, that'll match all of them. And then this is something which I was kind of, okay, so this will match a comma. So what do I have here? I have a space or a comma. So that'll match a comma, it'll match space, comma, space, it'll match a tab, it'll match a tab. Oops, that should be a comma. And that. Okay, so now how, kind of using these, Java was, well, it wasn't the first. Actually, I think Perl was the first major language to really incorporate regular expressions into the language itself. Java was, if not the second, one of the follow-ons. Okay, so if I have a string, strings have a method called matches, and if I give it a regular expression, it will be true if it matches the string and false otherwise. So just built into the language, I can start doing these. It also has something called replace first. So if I give it a regular expression and give it the replacement has to be a specific string. I can't put a regular expression there, but it will replace the first. Well, it replace first. It replace the first match. So if I say hi to mom, if I replace the first occurrence of a digit with a space, then that'll give me hi mom. But if I do the same thing with hi to mom too, it'll replace the first one but not the second one. Say, well, what if I want to replace all? Well, replace all, you say replace all. So now I replace all single digit ones with, so that'll replace this one and it will replace that one. And if I'm worried about maybe having one or more of them, then I can just put a plus there. And I know just 1 minute over, but I do want to at least touch on this because this is a really useful thing. I guess I'll have to pick it up tomorrow. But split is I can take a string and it returns an array of strings with the regular expression as the delimiter. So for example, if I say hi comma mom and I split it on the comma, it will give me an array consisting of the two pieces. And likewise, if I have like hi and then some white space and some more white space here, if I split it on one or more white spaces, it'll give me all of the different pieces. And the main use case for that is processing comma-separated files. So, and the best way I found to do that, because the contents can be strings and numbers and other sorts of stuff, is to kind of read it in a line at a time and then split it based upon like either the comma or whatever the delimiter is, and then process each of the individual pieces. We'll see that tomorrow. But also tomorrow there's another topic that the book unfortunately did not talk. It's called nested classes or inner classes. There's an online tutorial about that, so I want you to check that out. And tomorrow I'll give an example of using regular expressions to split, and then we'll talk about these inner classes, which are important for a number of different examples. I have a little example to show you for that. So, okay, so I will see you then. Thanks for staying a little over.